Hello and welcome back to another episode of Math with Son. Now, this problem is quite unique, and we're trying to figure out how tall is this table. And I'm telling you right now, it is not 40 centimeters, okay? There are two kind of ways to do this. The first way that we're going to do is going to be with a mathematical operation where you recognize that this table and the cat put together would equal the turtle plus 170. See how the turtle and 170 is equal to the table and then the cat? So we're going to write that. We're going to do table plus cat would equal 170 plus the turtle. Okay. Now, that in and of itself would not allow us to know how tall the table is by itself. But with the other scenario where we have the cat added with 130 is the same thing as the table plus the turtle. So here we're going to do table plus turtle. Turtle is equal to 130 plus the cat. All right? And what we're going to end up doing is anytime you have two equations with two variables, you can set up what they call a systems of equations. So we're going to rearrange these and make it to where we can solve. So I am going to subtract the turtle over, and I'm also going to subtract the cat over. And when I do that, I end up with the table plus the cat minus the turtle would equal 170 over here. And here we'd have the table minus the cat, because we're subtracting the cat over, plus the turtle would equal 130. All right. Now we're going to take these two equations and line them up like one on top of the other. So we have table plus cat minus turtle equals 170. I'm going to put it right over here. We're going to do table plus cat minus turtle equal 170. Table minus cat plus turtle equals 130. Now with a system of equation, if everything is lined up, you can add straight down, and in this case, when you add straight down, the cat and negative cat cancel, turtle, negative turtle, positive turtle cancel. You end up with two tables is equal to 130 and 170, 300, which means a singular table is equal to 150 centimeters. Okay, first off, kind of a small table maybe. Now that is one method. That method is mathematical, okay? The other method that I find to be more akin to believing how it actually is if you're not a mathematical person is if you take the two situations and you stack them one on top of the other. So I'm overlapping the turtle here, and I'm looking at this, and essentially from top to bottom we have some things happening here. We have the cat on the bottom, then we have 130, and that 130 overlaps the other turtle because the turtle originally was on the top of the table. So that 130 includes that bottom part right here. So essentially, we have from the top of this cat, which I drew a line, 130, then 170, okay? Which when we combine 130 and 170, you get 300. So we have 300 from the top of this cat's head to the top of that cat's head. And that 300 includes almost two tables, but it's missing this extra cat. So if we could take this extra cat, which is a part of this 170, and move it down here, then you would end up with 300 for just two tables stacked together. So if we have the 130 and then the 170 with an extra cat, and that extra cat is essentially the bottom part of the table that's missing, that means that 300 is equivalent to the two tables, which again is 150 centimeters for a singular table. All right, that's going to do it for this one. Until next time, everybody, stay positive, and I will see y'all later. Bye.